Sorry. All right, we're going to pick up where we left off. And quantum numbers. Here we go. All right, so we talked about electrons and how electrons are in their lowest allowable energy state, and we call that a ground state. Our electrons then, when they're in that ground state, are not excited, but they can get excited. So yesterday in lab, we excited our electrons in two different ways. What two different ways did we excite electrons?
We did
Heat with the flame
electricity.
and electricity. So those were the two ways that we got them excited. Okay. So electrons are only allowed in certain energy levels. The smaller orbits, which are closer to the nucleus, have a lower energy associated with them because they're not as far away. Okay. It's kind of like thinking of falling off a ladder, right? You fall off of the first rung, you don't have a lot of energy when you hit the ground. So you're probably not going to do much damage. Although, who knows what I would do, being the klutz I am. If you fall off the top rung of the ladder, though, you're going to have a lot of energy when you hit the ground. And that will probably do more damage. Like, mess up your shoulder and make you have shoulder surgery. Back in 2013. Actual true story, fell off the ladder. Okay. So hydrogen only has certain allowable energy levels. So we can draw these energy levels. So remember when I said that we were going to use the Bohr model of the atom, where he has these, the actual model that they've kind of adopted now for the modern thing is that we are 90% certain that an electron is in this region. And then they use the Bohr model to kind of show that. So that's kind of the difference between them. The hydrogen then has a clearly defined, or the orbitals aren't clearly defined, but we have kind of an idea of what they look like. And we can use these quantum numbers kind of like a zip code. So if you think about like your address that you have at your house, or let's just use the one at Craig here. Okay. So Craig, if I was in England and I wanted to send a letter over to Craig High School, how would I address that? You don't have to give me specific like values or streets or anything like that.
Craig High School.
Okay, but we want to narrow it down first with our address. How are we narrowing it down to get right here?
Janesville, Wisconsin.
Okay, but we're in England. So do we know where Wisconsin is? We want to narrow it down first. Right, we're going to send it to USA. And then we're going to be able to narrow it down to Wisconsin. And then we're going to narrow it down to Janesville. Then we're going to narrow it down to a region within Janesville. How does the Postal Service narrow down regions in Janesville? We have about 4. Zip code. Okay. So they're going to narrow it down to a region in Janesville using the zip code. And then they'll go by street. And then they'll go by house number. Okay. Fire number, whatever you want to call it here. Okay. So that's how they do that. We are going to use quantum numbers to act kind of like this zip code. All right. So for example, Wisconsin, all of our zip codes begin with what? 5 and then 3. And if you're up north, it's 5, 4. Okay. So those are the two beginnings of our zip codes here in Wisconsin. So you kind of know which region. If you see a 5-4 zip code, you're like, oh, that's northern Wisconsin. Okay.
What about the other areas?
5-3 is down here in the southern area. So your zip code is 5-3, blah, something. So like Milton is 53563. Janesville is 53545, 46, 48, depending on, like west side we're 48. Okay. Downtown's 45. Right here, I think it's still 4-5. So you can kind of narrow down parts of the town. 4-7 is the post office boxes. So if you have a post office box at the post office, it's 4-7. So, but we only have 118 elements that we have to define here, not a whole country. Okay, so we only need 4 numbers, and I'm going to show you how you can figure out what element each quantum number is associated with today. Okay, so the first thing you're going to do on your paper is you are going to notice that, and you need to block off this guy right here. If he isn't already, I think I have an X through yours.
Yeah.
Okay, you're going to mark that off, and helium is actually going to come right here next to hydrogen. And I'm going to explain why as we move through this. So you're going to label this box H and this box next to it HE, because this is hydrogen, this is helium. Okay? So for the rest of the year, helium's going to be over here where we block this out. Okay? But for quantum numbers and electron configuration, which we're getting into, okay, that helium's going to be over here. Okay, so just for this unit. Good?
Okay.
All right. You are going to take a pencil of your choosing, and you are going to color the first 2 columns here the same color. Shade it in. Don't do it super dark. And then at the bottom here, you are going to label that S block. I'm trying to see if I can make this bigger.
Do we have to like label the elements?
Nope. Don't label the elements. I'll show you how to use it. This is not for geography class. You are not doing this map perfect. You are simply shading this in. You have like maybe 30 seconds to do it. Go. If you're doing it better than that, you're doing it too well. Okay, 30 seconds. You should be about done. Down at the bottom,
What do we
you're going to call this S as in Sam block, or Sophia, or Sophie. S. This is your block. Ladies, excited? You got a block?
Sure.
You don't seem excited. All right. Then you're going to come over here, and you're going to find the last 6 columns. So it starts with 13, 14, 15, 16, 17, 18. That block, you're going to color in a different color, and you're going to call this P block. P is in Paul, because I don't have anybody with a P name in here that I can pick on. Maybe we have some P names for middle names. I don't know. You're still in pumpkin spice season, y'all. Then we move into eggnog season.
I don't mind eggnog.
All right, you good with that? Everybody cool with that one?
Yep.
Now we're going to move into the middle. So the middle, not the bottom 2 lines, just the middle section. You are going to color this middle section in another color, and you're going to call this D block. I don't have any D names in here either. D is in David. Somebody might have a middle name David. I don't know. All right, you about done? About done? If you're not about done, you're doing it too good. All right, last section. Did you get this one done as D block? Is this labeled D? D is in David, Diane. Other D names. Dinosaur. All right. Last section. You're going to color in another color, and this is F. F block. F is in Frank.
This entire bottom?
Yep.
Okay.
Both lines. Yep. The whole thing. F is in Frank. Franny. Francine. Other F names. Faith. Faith is a common one for your generation still. And that's it for those, for the coloring. So you can bundle up your pencils then, if you'd like. I'm done with them for now. Minka? I will try to get you one of these too. Get Haley to make one of these for you. All right, everybody good? All right, so now I'm going to move this and it's going to pop me out of here. Yep, I knew that. I don't understand why it has to do that every time, but it does. Now we're going to start identifying the different parts of the quantum number. So the first part of our quantum number, the first number is going to tell us how far away we are from the nucleus. We call this N, as in Nancy, I guess. I don't have any N names in here. So N is what this is called. The values range from 1 to 7. So you can kind of think of this as floors in a building, how far away you are from the ground or the nucleus. So for each one of these, how far are you away? So the options here are 1 to 7, and it just tells you how close you are. So this is, if we have N equals 1, that's our first level, N equals 2, it's our second, and so forth and so on. Okay? So up in the very, very top corner, you can kind of see a faint shading of lines there. Way up in the top corner here in that first block, you're going to label that N as in Nancy. So write the letter. All right. Well, you can kind of see right there. They're starting to show up. Yeah. So. Yeah, you'll just have to draw them in then, I guess. Sorry. So there's 4 lines. Do you want a ruler? I can get your rulers. Oh. You can kind of make a few of them out if you really squint hard. Sorry. So sorry. Eric, you want one? My bad. It's okay. Okay. So then I'm going to work you around. Still a better day than yesterday. We can roll with it, right? Yes, I'll add that to my supply list at the beginning of the hour then. All right, so off to the side here, you're going to have these 4 boxes here, and then you're going to have, yeah, and then we'll start dividing down. All right, so for the S block here, you're going to call that period. So write the word period next to N for this S block. And then you're going to number down the side here 1, 2, 3, 4, 5, 6, 7. Okay. And period, it's going to be the period. So if I asked you for the n value for this guy right here, where the red dot is, what would the n value be? 3. Okay, does that make sense? All right. Then go all the way over here, and for the P block, write in period as well. So anywhere that you're at in the P block, if I ask you the n value, you will tell me whatever period you're in. So if I am here, what is the n value for this guy? The red dot. What period am I in? 2. So that is my n value for that particular element. Easy enough? All right, you ready for D? Okay, all right. So D, your n value is going to be period minus 1. So whatever period you're in, you're going to subtract 1. So my D value for this guy right here, or my n value for this guy right here would be what?
Which one?
Right here.
Would that be 5?
5. Yep. Because 6 minus 1 is 5. So that's what its n value would be. Now, before we go on to F, I want to show you how the periodic table actually is. Okay? That F block is actually tucked in to this area right here. Okay? So this is how that meets up. So see, you can see sequentially here that it goes 56, then we go down to 57 down here. Okay? We go all the way through to 71 or 70, and then 71 is back up here again. See how that works? Okay? So this is actually what your periodic table looks like, a real long thing like this. But these are all like rare earth metals, or they're radioactive. We don't use them very much. So that's why they just tuck them down here out of the way. So that this is a more convenient format for you to be able to kind of carry around in a notebook and stuff like that. But this is what that actually looks like. So when you are down here, this is actually period 6, and this is period 7 for these F block elements, because they fit right up into this section. Does that make sense?
Yes.
Okay, so that's why these are 6 and 7. People are like 8 and 9. No, it's not 8 and 9. It's 6 and 7 because they came out of this little inset right here. That makes sense? All right. So when we get down into the F block, your n value is going to be period minus 2. So period minus 2 for that guy. So if I am this element right here, what is my n value? 4. Because 6 minus 2 is 4. Easy enough?
Yes.
All right. So the next section is angular momentum. And this tells us what type of orbital we are dealing with. Okay? We have 4 different options. We have an S, a P, a D, and an F. And you know what they are based on their location. You've already color coded them, right? Because you know all the S ones, you know all the P, You colored them in a few minutes ago. Okay. This is kind of what they look like. So an s orbital is like a sphere. Remember, this is a two-dimensional drawing of a three-dimensional object. So this is a sphere. This guy, the p orbital, is kind of like a peanut. They call it peanut shaped or dumbbell shaped. Your d orbital is almost like a clover leaf. It's got 5 different lobes coming out of it. And then your f orbital is just a hot mess. It's just a complex piece of mess. Yeah, it's a lot going on. Okay. We assign then a number to indicate what these are. So if you are in the s orbital, the number is 0. So if you see 0 for s, that means that it is, or I'm sorry, for the L number, that means that you're a sphere. P is 1, D is 2, and F is 3. And I had you color these in this sequence. Okay, I had you do the S, I had to do the P, I had to do the D, and then the F. I did that specifically so you to remember how these go. So underneath the letter N, you are going to have the letter L there. That is the second part of your quantum number. If you are in the S block, the value for that is 0. If you are in the P block, the value for that is 1. If you are in the D block, then the value is 2. Right? Did you get those numbers on your chart? Again, I'm sorry for the faint lines.
So it's 5. It's 5.
Okay. I don't want to make extra work for people. Yeah, you got it done. It wasn't too bad. All right, you good with us? Ready to do F?
Yes.
So then F block, your L value is always 3. Good? Okay. The next one tells the spatial orientation. So you know how in graphing you have like an x-axis, a y-axis, a z-axis. Well, there's a couple other axes out there, okay? Because it's not just this, and this. There's also stuff in between. And so for these, we have stuff in between when we get to D and F. So for this one, the options are 0. For P, it's -1, 0, 1. For D, it's -2 through +2, and F, it's -3 to 3. Okay, so how do we mark that? We're going to put an M underneath the L here. And then if we're in the S block, we only have one option, and that's 0, because it's a sphere. So there's no specific like indication of how that is oriented, because it's a sphere. So no matter how you turn it, it's still going to look the same. Does that make sense? As opposed to like a P orbital that looks like this. If I turn it this way versus this, you can see a difference in orientation, right? Okay. So when we get over to the P orbitals, we're going to have -1, 0, 1, and then we repeat that.
Oh, I see.
And we'll talk about how we distinguish between -1 and -1 in just a second when we get to S. Okay.
Oh, I didn't write. Oh, I didn't write those lines down.
You okay?
There's 2 ones in the middle.
There's 2 what, huh? What?
There's 2 ones in the middle. 2 ones. On the alternating.
Well, this is a -1, 0, 1, and then we do it again, -1, 0, 1. Good? Okay. All right, ready? Okay. When we get to the D block, we're going to go -2, -1, 0, 1, 2, and then we repeat that. So you should have 10 values in there. Can you wager a guess how many the F block's going to have?
14.
14, right. Okay. So for the F block, you're going to start by numbering this one -3, -2, -1, 0, 1, 2, 3, and then you repeat that.
Mark them in the boxes? Or
Yep, you just put them in the boxes. That will apply for the ones underneath them too, but I'll show you how to distinguish them as we move through, okay?
Oh, this is a bad color.
Do you want a Sharpie? I can give you a Sharpie if you want. Oops.
Oh, maybe you can use a pen actually.
Okay.
Thank you. Yes, that's it.
All right. I'm gonna trip over this thing.
0.
I've ordered 3 different cables in to try to fix this. None of them work. So I gotta run by and return everything to Amazon this weekend. Yeah, it's just crazy. All right, so that takes care of our M value. Now we've got our last one that is spin. Spin can either be clockwise or counterclockwise. We indicate the difference between clockwise and counterclockwise with a plus or minus. Now, some places you might see it +1/2, -1/2. You don't really need to put the 1/2 there, but if you get into college, they may make you. Okay? So we just do plus and minus here. So if you're in this column, you're going to be a plus. If you're in this column, you'll be a minus. When we move over to P block, you're going to do 3 pluses in a row, followed by 3 minuses in a row.
Oh, I see.
Told you it'll make sense. It'll start to come together. All right. D block, 5 pluses in a row, followed by 5 minuses. Guess what your F block is going to be?
7 pluses, 7 minuses.
7 pluses, followed by 7 minuses.
How'd you get?
Magic.
There's an answer? It's a pattern. It's all in the pattern.
That's what science is patterns.
What's happening?
All right, good? Pretty cool? All right, so this is what your chart minus all of the letters in here. This is what your chart should look like. Now, as you're going through and you're finding different elements on here from your periodic table, write in what the abbreviation is. But you don't need to go through and fill all of this stuff in. You'll get it along the way, okay? So when you're told, so for example, let's say that you were told to find chromium on here. You want the, well, let's not start with chromium. That's a little harder. Let's start with chlorine, okay? So what you do is you find chlorine on your regular periodic table, and you find it over here on the chart. So chlorine will show up right here on your periodic table. Okay? So once you find an element on there, write it in. Does that make sense?
Yes.
But you'll always have both of these. Like when you take a test, I will give you my copy of the quantum number. I'll give you a copy of this to use on the test. So it'll already be filled out and everything. And you'll have a copy of the regular periodic table that you can use together to find stuff. Okay? So let's figure out the quantum number for chlorine. All right? So what you do when you find your element here, you're going to follow this all the way up, and you're going to start here with the N value. Okay? So this is chlorine. It says for chlorine that whatever period I'm in is my N value. So what is my N value for chlorine? I'm going to go all the way over here. It is 3. Okay? Then I just follow down. So 3, 1, 0 is my next thing that I'm following down. Minus. That is the quantum number for chlorine. So how is that different from phosphorus? Because phosphorus, what is my period?
It is 3.
3. Phosphorus is, then we keep going down. 3, 1, 1, plus. Okay? You see how this works?
Yes.
So you can tell the difference between each of these elements. Good? Okay. Let's try a little bit harder one. So underneath the number 8 here, in the D block, in the first row of the D block, write in Fe. That is iron. We're going to do the quantum number for iron. So again, I go all the way to the top here, and it tells me for iron that my N value is what?
4 minus 1.
Right. Period minus
Sorry.
1. I'm in the 4th period, so I'm going to do 4 minus 1 will give me 3. And then I just follow down. 2 minus 2 minus. Is it making sense?
Yes.
I need you to slow down a little
Okay.
bit. So let me minus. All right.
All right. What about LA here? Let's do LA is right here. So what is my N value for LA?
It's 4.
Yeah, 6 minus 2 is going to be 4. My L value, anytime in the F block, is always 3. And then I'm going to have negative 3. And then I look down here for the spin, which is a plus.
That's cool.
So every element on the periodic table has a unique quantum number.
3.
For this, my L value is always 3 when I'm in the F block. Good? Okay.
A little confusing, but
Well, you have to practice with it a little bit, but it comes. And like I said, you're always going to have this periodic table with you. So you're not going to go into it, with having to memorize how this works. Although you might accidentally memorize it along the way, but it's not an expectation. All right, so here are some examples of quantum numbers. So, and elements. Okay, so we want to over here, find the quantum numbers, and over here, you're given quantum numbers, and you want to find what element it is. Okay? So let's attack these first over here where we're given the elements because they're a little bit easier. And then I'll talk to you. There's a method for this that makes it a lot easier.
All freshmen need to report directly to the cafeteria for advisory today. Again, all freshmen, you are to report directly to the cafeteria for advisory today. Freshman advisors need to report to room 809. Thank you.
Allie, what time do we get out? 33? Okay. All right. So I've already talked about a few of these over here. I want to focus in on these real quick because it looks like we're running a little low on time. So the first thing I do when I'm trying to identify one of these elements, so this is 3, 1, minus 1 plus. 3, 1, minus 1 plus. That's what's written down there. Okay. The first thing I do is I look at the L value first. So I look at that value. This is my first place that I go to. And the reason why I do that is because it's going to narrow down what part of the periodic table I need to be in. Okay? So this is 1. That tells me I'm going to be in this section of the periodic table. Does that make sense?
Yes.
The second number then that I look at is this guy. So I look at him next. I see that when I'm in the P block, whatever period I'm in is that N value. So it says a 3. That means that I'm somewhere in this section. So now I've narrowed it down to this section of the periodic table. Then I look at this value. Now I've narrowed it down to these 3 elements. And then lastly, I look at this one. So that's the sequence that I go in to try to figure out what I'm dealing with. So this was a plus and it was a minus 1. So it's this guy right here, which I believe is aluminum.
Yeah.
So that is the answer to that problem. So that is aluminum. Okay. 4, 3 plus
Oh, I see.
3 minus. 4, 3 plus 3 minus. 4, 3 plus 3 minus. All right. Again, I'm going to start here. What block am I in?
We're looking for 3 for L, so we're
F.
gonna.
So I am in this block right here. So now I'm focused on just that section of the periodic table. My value here, the next thing I look at is this 4. Well, if I go back over here to figure out how we got that 4 equaled period minus 2. So what minus 2 will give me 4? 6. So I know that I'm in this section right here now. Does that make sense?
Yes.
Then this is a minus. So I know that I'm down on this line. I know that I'm in this section right here. Okay, because I know I'm a minus. And then I'm a plus 3. So it must be this element right here. So what is that element? I go back to my periodic table. It is YB. So my answer, I don't know. So my answer here is YB. Okay?